The slides and recording of this webcast will be made available for viewing later today and can be found on the SANS webcast archives. And with that, I'd like to turn the webcast over to John.
Thanks so much for that introduction, Jessica. Welcome, and thank you for joining us today. I'm excited to get started. So first, let me just kind of introduce my esteemed colleague here, Vince Stouffer, Senior Director of Product Management here at Corelight. Vince, maybe you could talk a bit about your background, just because you kind of came from the operator end user experience, so you've just got so much kind of insight and perspective on this particular challenge.
Hey, hello everyone. Thank you for joining us today, and thanks, John. Yeah, I come from a network background originally, and then moved into security when that really started becoming a thing, and spent a lot of time using Zeek and other network security tools, and really that led me into the ability to go and join Corelight and share Zeek and the power of that data with the rest of the world. So excited to tell you a little bit more today about how we can work with encrypted traffic and show you without decryption a lot of the power of the Zeek and Corelight data.
Great. And I'm John Gamble, Director of Product Marketing here at Corelight. I've been with the company for almost 3 years now, and I know enough technically to be a little bit dangerous, definitely not as technically savvy as Vince, but I've had the pleasure of getting to meet with SOCs kind of all over the world in my career over the last 10 years and talk to them about the problems they're facing and really dig in on the technical solutions. So I'm excited today to talk to you about some of the things I've learned here at Corelight over the last 3 years that's really resonating with our customers in the open source community in terms of ways that this incredible data set and tool that is Zeek can be used to help with this challenge of increasingly traffic being encrypted on your network and the visibility challenges that can pose. So the agenda, real quick, we're going to kind of dig into this encryption challenge a bit and talk about kind of some of the nuances there of why this is such an important topic and something to address and something that really should be at the top of your list in terms of priorities to address in your SOC if you haven't already. Next, we'll talk about Zeek. So Vince mentioned it, and I've talked about that word. If you're not familiar with the word Zeek, Zeek is an open source network security monitoring tool. We'll talk a bit more about what it is, the history of it, and how it works. But it's been around for quite a while, and it's a favored tool of leading blue teams in the world to get visibility into their network traffic at scale, whether that traffic's encrypted or not. So we'll talk about what the capability set are to frame the meat of today's presentation, which is the 7 analysis use cases we're going to present. These are 7 specific ways that you, using Zeek data, can actually address encrypted traffic and look for evidence of adversarial movement in your environment. And we'll close with a Q&A. So feel free to ask questions at any point during today's broadcast. In the Q&A box, we'll see that, and we'll probably save questions until the end of today's presentation. We'll try to save 5 to 10 minutes for Q&A, and definitely stick around for Q&A. There's a special offer that has been pretty popular that I'll reveal during the Q&A, so stick around. You won't want to miss that. So the encryption challenge, right? You signed up for today's webinar because presumably you want to learn more about kind of how to deal with encrypted traffic in your environment. And if you're talking about a typical corporate network, safe to say that a majority of the network traffic in your environment is probably encrypted. These stats here come from a Gartner kind of predictive source, and saying up to 80% or more of encrypted web traffic in the enterprise is kind of where we're looking at today. So, throw a dart on a board, hit a packet, it may well be encrypted in your environment. Now, of course, encryption is great from a privacy and security perspective. From a defensive side, it keeps your data safe, your customers' data safe. It's great for IP protection, and it's great for keeping the bad guys out of those communications. But on the flip side, of course, adversaries are also using encryption, and in fact, many attacks today have some component of them that are encrypted, if not an entirely end-to-end encrypted attack. So you need to not only kind of be cognizant of the encryption running in your own environment that's known and good, but recognize also that some of the tools you may have relied on to do network security in years and decades past are starting to become less effective because some of those traffic streams that the adversaries are in, some of their connections are going to be encrypted. And if you're doing kind of an approach that requires, clear text or break and inspect, you may run into some challenges there, and you may not have the visibility that you previously relied on. And Vince, maybe you could talk a bit more about kind of the emerging kind of encryption standards and how that kind of even further complicates the picture here.
Sure. And, of course, we've moved through generations of different, encryption protocols that have been the standard for web and other protocols, right? The TLS, and then into, SSL, and then into TLS. And so, the current version of TLS 1.2 that is in the most amount of use allows us still to gather a whole lot of metadata. And we'll talk about that later in the broadcast. So even though the bulk of the connection, the entire payload, and the communication is encrypted, the capabilities exchange, the certificates, everything else at the beginning of that connection is unencrypted, and gives us a lot of information as defenders to be able to see what's going on in that traffic. As we move to TLS 1.3, it becomes harder and harder, right? There are some things built into the specification for TLS 1.3 that guarantee end-to-end encryption, that make it harder to do break and inspect, and also protect the capabilities of exchange and the certificates, especially, are completely encrypted in TLS 1.3. So it reduces our data a bit more. It complicates our ability to kind of do some of the stuff that we're talking to you about, but it doesn't preclude us from doing some of the same tricks, right? And it doesn't shut down all avenues into being able to have some visibility into what's going on with those connections, even absent any sort of other decryption. But it's just worth noting that things are getting harder and harder in this arena, and TLS definitely makes that harder, right? You're still able to do decryption if you own the servers, and these are services you're providing to customers. But in the other direction, from your customers or your employees going out to the internet, it's going to become a lot harder to get the sort of visibility that we currently have.
And so, naturally, kind of, I think one response I hear when we talk about this problem is, well, yeah, why can't I just decrypt that traffic? And of course, decryption, is going to ultimately provide maximum visibility. If you're decrypting that payload, you're going to be able to see what's in there. You're going to be able to do, analysis of that payload. Of course, the visibility there is maximal. But the reality of decryption at scale in a modern enterprise environment is a lot trickier than just simply sweeping a wand across and decrypting all of that traffic. There's a number of reasons we find in our customer base and the open source community that we see tackling this problem, that they're not decrypting all of their traffic, and it can be for a variety of reasons. And I've listed some of them here. Cost, decrypting all of your enterprise network traffic at scale, that can get pretty expensive pretty fast, and you may not have the budget to do that. There may be latency issues. There's no free lunch, and those latency introduced by decryption may be acceptable, may be so minor that it doesn't really impact your services or kind of perceived connectivity, but it might. And if you're transferring huge volumes of data, or you have huge throughputs that require extremely fast speeds and near zero latency, that might pose a problem to you if you're trying to decrypt some of those large flows or high throughput connections at scale. Regulation, compliance, and privacy is another reason we hear for people choosing not to decrypt in their environment. You might be in a regulated industry that decrypting said traffic of your customers might violate certain laws with respect to regulated industries. You might be operating in a GDPR compliant zone or area of data that also would prevent you from decrypting